In this exercise, we're going to use indexing and multi-indexing to do some data selection operations. Now, once again, we've done some of these operations in the past, and we had to use masking for selecting based on the values. Simply because this data frame doesn't have any meaningful index, it has the default index which ranges from 0 to length -1. On the other hand, we can rely on indexing to select the data rather than masking. Let's take a look at some of the questions. First, we need to select countries in Asia. Second, we need to select countries in Asia in years 1952 to 2000. And finally, we want to do the average of population in these countries. Okay, so I'll probably do it in different ways. I'll probably use masking first, but then I will use indexing to show the difference. Again, the question is asking us to use indexing rather than masking. Nonetheless, let's do it using masking. So, countries in Asia. The first step is to create the mask. So, I need to go to my data frame and pull the series, which is continent. Now, this is a series. If I do series equals to Asia, what happens? Well, pandas will broadcast this operation to all of the values, and I get a series of Boolean values, and this series is called a mask. Now, I can use my mask to select these entries from the data frame using the indexing the bracket operation. This will basically give me all of the countries in Asia in a new data frame. Once again, I can save this data frame to another data frame if I wish, but basically that's essentially what I need to do. Okay, now let's do this using indexing. While using indexing, first we need to change the index of the data frame. So the first step is to set the index to be continent. I get a new data frame in which the index is continent. Once I have an index, I can use indexing. Because I want to pull continent to be Asia, I need to use lock, and then I need to specify the value, and I only want Asia here, so I'm going to say Asia here, right? Lock Asia is going to give me a subset of this data frame. The values are Asia. Now notice that we've got the same number of rows. Obviously the number of columns differ here because here the continent is on the index, is not a column. If I want it to be a column back again, I can reset index. Again, the question here is not asking us about, is not specifying the details of the data frame exactly. If I wish it to be a column, I can reset the index back again and I get exactly what I had before. 396 rows and 6 columns. The second question is asking us to do the selection, but there are both two criteria. First, country is Asia, and second, year has to be 1952 to 2000. So what we can do in this example here, we can use masking. In this case, we need a composite mask. The composite mask needs to contain all of the criteria. So first, data, the continent should be Asia. Second, year has to be greater or equal to 1952 and less or equal to 2000. So I'm going to copy this. Year has to be greater or equal to 1952. And here I'm not sure if 1952 is encoded as a string or as an integer. Just really quickly, I'm going to peek at the D types here, and the data type of year happens to be an integer, hence 1952. And I need this to be less or equal to 2000. What I get here, I get a subset of the data frame that satisfy these criteria. Continent is Asia and year in between 1952 and 2000. Let's do the same using indexing. Here I have multiple options. I can either index on the continent and then pull the year using one mask, or I can index on the year and then pull the continent using a mask, but I'm going to do a multi-index. So what I'm going to do here, I'm going to create another data, let's call it data 2, and I'm going to set date index on data to be continent, and year in this case. Let's take a look at what we've got here. So we've got each continent in all of the years. Next, I'm going to access the index slicer object. And this is because I want to slice on the second level, which is year. So what I'm going to do, I'm going to access the index slice here. And what I'm going to do, I'm going to go to my data here and do lock, and then I want it to get me Asia. Okay, so before we slice on the index, let's see what we've got here. I'm going to get all of the years, and I also want to get all of the columns for now. So what I'm saying here is that we'll take a look at this data frame. It has a multi-index. So what I'm saying here, we'll look at this multi-index. I want the first level to be Asia. The second level should be everything. This is the second axis, which is the column axis, and I'm telling pandas to get me all of the columns for now. So what I get a subset of Asia here, right? Well, the second step is to be more specific here and to say, look, I want years from 1952 to 2000. Now, this will give us an error, and the reason it's give us an error is that this data is not sorted, and when we are slicing, we are assuming that the data is sorted. Otherwise, the slice may not be accurate. You know, you can go in 1952 to 1942 to 2000, right? So, as a validity check, pandas will not allow the slicing operation if the index is not sorted. If you want to sort based on the index, we can call the function sort index. And this will basically, let's see what it does. It basically creates another data frame in which the index has been sorted. And you can see now it's been sorted on the two levels. First sort by continent, and then in each continent sort by year. Okay, so once we do that, we can chain the lock operation to this new data frame. I can take Asia 1952 to 2000, and we get the slice that we're looking for, 1952 to 2000 in Asia. Okay. That's one way to do it. If we don't want to sort on the index, we can sort on the values prior to creating the data frame. Actually, let me keep this one here as an option. We'll go back to this. Instead of sorting on the index, I'm going to sort the values of the data frame prior to creating the index here. So let's go back to data here. Here is data. And let's say I want to sort per continent. I can do sort values continent. Now, the values are sorted per continent, but you can see that the years are not sorted within the continent. For instance, we can see Africa 2007 comes before Africa 2002 and so on. If I want to sort based on multiple columns, I can do sort continent, and the other column is year, and you can see now we have sorted based on continent and then year. So what I can do in this case, I can do this sorting operation prior to re-indexing the data. So I can do something like this. I can do data.setIndex. Prior to setting the index, I'm going to sort the values. So take this one here and sort the values and then set the index. And this will give me a data frame in which the index is already sorted because I've sorted the values prior to creating the index. Hence now I can do something like this and it will give me the same answer. Once again, if I need to convert it back to a data frame in which continent and year are columns, I can reset the index. And I will get that done here for me. Okay, now the last question is basically asking us to, based on this result, calculate the average population of countries in Asia in years 1952 to 2000. So what I'm going to do now, I'm going to assign this to data 3. That's my data 3. Next, data 3 here is a data frame. So what I can do here, I can do data 3 population, and I can do the average. The other way to do it, if I want to do it in one shot here, take a look at this indexing operation. This indexing operation is basically telling me that on the multi-index, give me the continent and a slice of the years, but it leaves the column axis completely open. So that's not what I want here. I want population on the column axis, which will give me a series, because population is a column on the column on the column axis. In this series, I need to calculate the mean, which will give me the same result. Which one is better? I don't have a preference really. If we want to access this data for multiple operations, it makes sense to store it in its own variable, such as data 3. Now, on the other hand, If we just wanted a one-shot operation, we probably can do that in one liner. And you can see here that one of the design philosophies in pandas is not to change the underlying data frame or series, but basically return a new data frame and a new data series. This basically allows you to chain operations. So for instance, if I want to answer the question here at the end in one liner, I can say, okay, take data, sort the value, set the index, get the location, slice it, and take the mean, and you will get to the same answer. Obviously, this is not very readable, so it's not really advisable to do it, but it allows you to really do some powerful operation really quickly. You just kind of check some values and do some quick calculations.